Hello my dear learners, welcome you all to the course on signals and system. So in today's class we will discuss continuous time and discrete time signal and periodic and aperiodic signal. Later on we will discuss deterministic and random signal. Let me start with continuous time and discrete time signal. I have shown two graphs over here. So the first one is belongs to continuous time signal and this signal belongs to discrete time signal. What I mean by this continuous time signal, here the independent variable time which is continuous. Okay, I can't pull out one value from here and I can tell the amplitude of the particular signal x of t. I can't tell like that. Okay, it is continuous over the range. Whereas in the case of discrete time signal, x represented by x of n, the independent variable time n, the independent variable is represented by the variable n. Okay, so here the value of the signal is defined over only at integer values of the independent variable. Okay, the integer variables, so you can see over here 0 1 2 3 4 5, only at this particular integer values of the variable n I can have a value of a signal x of n. Okay, only for integers. So this is very important point. So later on we will remind this concept. We will use this concept in various problems. Okay, so for integer values, if my signal is defined, then that is discrete time signal. So if it is continuous over the time, it is continuous time signal. Okay, let me move on to next class of signals called periodic and aperiodic signals. So throughout this course we will discuss only those continuous time signal and discrete time signal. Let's discuss periodic signal. So to satisfy, if I can say a signal is a periodic signal if the signal x of t satisfies the condition x of t plus m into t. Okay, so where m equal to 1 2 3 etc. Let us consider the signal x of t and we take m equal to 1 value, then what I will get is I will get x of t is equal to x of t plus capital T. So this is x of t signal. Then x of t plus t means, so I have to shift my x of t signal by a time shift of t. Okay, so suppose this is the time interval t. If I shift by time t times, then my signal, this portion, okay, this portion will shift to here and this portion will shift to here, this portion will shift to here, this portion will shift to here. Okay, so therefore my signal x of t plus t also looks like x of t, right? So because I am shifting this port or this portion over here and this portion over here. Okay, so therefore the same signal x of t is equal to x of t plus t. Okay, subject to a condition that the signal x of t ranges over minus infinite to plus infinity. Okay, so this condition has to satisfy. So without this condition I cannot get x of t equal to x of t plus t. Suppose if I have a signal like this, the signal starts from 0, this is x of t, suppose if I am going to write x of t plus t, then I'll get the signal like this. Okay, this is over t. So therefore this signal 1 and therefore this signal 1 and this signal both are not same, because this signal has started at origin 0, whereas this signal started at the origin t. So both signals are not same. Whereas in the case of minus infinity to plus infinity range, even if I shift one time period by t, I'll get the same signal as it is. Suppose if m equal to 2, say in this case I have took m equal to 1, suppose if I take m equal to 2, I'll get x of t plus 2t. Even if I shift 2 times, I mean if I shift this signal over here instead of here, if I shift over here, I'll get the same thing, because the signal ranges is minus infinity to plus infinity. I'll get x of t equal to x of t plus 2t. Okay, both are same. Similarly, if it x of t plus 3t, I'll get the same thing, I will get the same signal. So this condition x of t, so whatever may be the signal that satisfies this condition x of t equal to x of t plus mt, then those signals are called periodic signals. So let us see this signal x of t plus t. So this signal, if I shift this signal by let's time period t, what I will get? So I'll get signal like this. This is x of t plus t. This is shifted over t times. This is origin. Now you see this signal and this signal are not same. So therefore this is aperiodic signal. Okay, so they both of the cases, both of the signals for continuous time case, whereas this signal, the third signal x of n, this is for a discrete time case. Okay, so here you look at that the signal. So this is origin, this is 0 1 2, again this is 0 1 2 3 4 5. If you look at that, this pattern, okay, this pattern repeats again and again. So this is a periodic signal, and also this signal is ranges from minus infinity to plus infinity. So therefore this is a periodic signal. With period, they have mentioned it is n not equal to 3. What I mean by this period is n not equal to 3. How many samples, after how many samples it is repeating. So this is 1 2 and 3. After 3 samples, again the pattern repeats, so that the fundamental period is 3. So in the case of continuous time signal, t naught is the smallest fundamental period, okay, where t is the smallest fundamental period. Okay, so in the case if we take the signal is periodic with the t, okay, 2t 3t 4t and etc. So therefore here the t is the fundamental period. Okay, in the case of discrete time case, here we will consider again the same case, whereas in the case of discrete time case we will consider the n value, the sample value. Okay, so we'll identify whether this is a periodic signal or not, where the time extends from minus infinity to plus infinity. Yes, this is periodic, because the same pattern repeats again and again. So now what is the fundamental period for this? The fundamental period is t equal to 1, because so from here 0 to 1 there is one pattern, and again this is repeated again and again. Okay, so if for example this is t, this is 2t, this is 3t, this is 4t. Okay, therefore t equal to 1. So again this signal is also a periodic signal with fundamental period t equal to 2. Now it's an example whether this signal is periodic or not. So there is a pattern at the origin, this pattern. Okay, so when we take t equal to 0, that is cos 0 we will get 1, sin 0 we will get 0. So there is a discontinuity. So sorry, there is no discontinuity. There is a pattern of signal lies at the origin. So this pattern does not come anywhere. Okay, so even if you plot signal, the signal x of t, the pattern at the origin does not repeat anywhere in the time extent from minus infinity to plus infinity. So therefore this signal is a periodic signal. Okay, again, now one can ask whether the unit step signal or the ramp signal is periodic or not. So let's how to check this. So we know the step signal is this one, u of t. So if I time shift by t times, that is u of t plus t, I'll get this signal. So both are not same, so therefore this is a periodic signal. Similarly, ramp signal, so we have here, and if I move it over here, so both are not same, so therefore this is a periodic signal. Okay, quite easy. So you put that pattern x of t plus t, e plus m into t, and check whether the pattern repeats again and again. Okay, so these are the two conditions we need to check over the periodic signal. And one more thing, the two interesting properties of the periodic signal are one thing is, if we time shift by t, then the signal remains the same, the signal is unchanged. Even if you shift the signal, the original signal x of t by t times, or 2t times, or 3t times, you will get the same signal x of t. Okay, so therefore the signal is unchanged by a time shift. So this is first property. And second property is the area under any one interval remains same for other interval also. For example, if we take 0 to t, if we integrate this over time, we will get some value. Then that value is equal for the time interval from t to 2t, and again 2t to 3t, it remains same. So this is the second interesting property of this periodic signal. So after discussing the periodic and aperiodic signal, let's pay attention to what is deterministic signal and random signal. So if we can able to write a mathematical equation for a signal, then we can classify that as a deterministic signal. So if we are not able to write simple mathematical equation, we can classify the signal or random signals. So I have presented 3 graphs over here. So this is deterministic signal, these two signals are deterministic signal, whereas this signal is a random signal. You can look at the pattern over here. This pattern is completely random, and we can't define a prescribed mathematical equation for this signal, so we can classify this as a random signal. Whereas these two cases, this is simple uniform distribution like pattern like. Okay, so we can write a simple mathematical equation for this. So this is mathematical equation for the signal, and for this graph this is a mathematical equation. So this is very simple equation. We can write equation for the signal. So this is classified as deterministic signal, and this one is a random signal. Okay, thanks for watching. We will meet another interesting lecture. Okay, thank you.